discuss about the data structure called queues. Queues, it's a normal word that we hear in our daily life. Wherever we go, we have a queues. When you go for a canteen, you have a queue. Restaurant, you have a queue. Go to doctor, you have a queue. Go to bank, we have a queue. So queue is the word that we hearing in our life every day in one or other aspect. So here the principle of the physical queue what we see is going to be used here to develop a queue data structure. Okay. So in the queue, people will be standing in a line, and the one who came first, he will be the first in the queue. And as the people are coming in, they will be added to the rear part of the queue. So that's the basic concept here. And who will be serviced to first? The one who came early only. So the first person will be served first. So that's the principle of the queue. So that's called first in, first out principle. Queue follows the first in, first out principle. FIFO. First in, first out principle. Okay. Yes. So queue is basically a linear data structure where deletion takes place in one end and addition takes place from other end. That's called we call it as a queue. So it's basically a kind of an array only. But only thing is how do we handle that makes a matter. So here you can see that here it's an array where you have some elements, array elements. If it is an array, let's say these are the array indexes. Randomly, we can access the array elements by calling, let's say the array is A. So A of 2, we can access the element. Understand? That is about array. The array also can be used to implement a stack as well. Stack means what? Where the addition and deletion will take place only from one end, which is called top. So if we want to insert a value, first we will increment the top by 1, then we will insert the top. We want to take the value out, we will take the value, then we will decrement the top by 1. But that is implemented based on the array only. Similarly, the queue is also can be implemented by using an array. So it's a kind of an array where the insertion takes place in one end and deletion takes place from other end. Generally, the deletion will take place from the front and the insertion will take place from the rear. So a queue generally it will use 2 pointers. Queue will use 2 pointers, namely front and rear. Front and rear. These are the 2 pointers. Front is used for deletion, removing the value from the queue, where rear is used for inserting the value into a queue. Inserting a value into a queue. Okay, so these are the 2 pointers that we use in a queue. What about stack? Yes, in a stack we use mainly we use only one pointer which is called the top, and we use another pointer called max stack. Just to monitor the size of the stack, we use this max stack. Okay, other than that everything is going to be similar. Okay, fine. So it's a data structure and it uses FIFO principle. So you can see that here a queue having 2 pointers called front and a rear. Front and a rear, and the values are loaded onto the queue, and addition, the insertion will take place from the rear, whereas the deletion will take from the front. Deletion will take from the front. How do we represent our queue? So the queue is basically a linear array, as I told you. A simple linear array can be used as a queue. Simple linear array can be used as a queue. So if it is an array of size n, so if we have the different pointers called front and rear pointers, then we can access the queue. So I'll just write it here, front pointer and a rear pointer, front and rear pointer. The front will be used only in the deletion, whereas rear will be used only for the insertion. Okay, so now, so linear array and having two pointer variables called front and rear. When queue is empty, okay, how do you determine the queue condition? How when the queue is empty, the front will be equal to null. The front will be equal to null. And for deletion, the front will be advanced. The front will be advanced. Front will be equal to front plus 1. It is be advanced by one position. Front plus 1. Similarly, for insertion also it will increment. So the insertion for what pointer we use a rear pointer. So the rear also will get incremented by 1. So that's a rear plus 1. So if it is empty, then front will be null. If it is deletion, front will be incremented. If it is insertion, the rear will be incremented. Rear will be incremented. Okay. So now let me give you the basic structure of a queue. So this is the basic structure of a queue, where you have a linear array. Linear array, when you say an array, it will have an index. Linear array, it will have an index. So like this, an array having index from 0 to 7, loaded with some values. Loaded with some values. Now, front is loaded with some 5,000. That means front is initially pointing to 5,000. That 5,000 memory address. These are the memory addresses. And what value is loaded here? 10 is loaded here. And the rear is presently it's pointing to. Rear is presently it's pointing to 5020. In the case when the new value is added to the queue, the rear gets incremented to the next value or next location in a memory, that is 5024. Similarly, when the queue, the first value of the queue is deleted, then front will be advanced to point to 5004, where it will be pointing to 15. So it means to say that, okay, we are not merely removing it, the value will be there. So we are just advancing the pointer so that it implements the delete operation. So from 5,000, it will be updated to point to 5004. That's how basically it is implemented. So we got to know now that a queue can be implemented by using a linear array. Linear array. Okay. So this is a simple implementation of a queue using a linear array. So as usual, we have the header files. So the header files are basically here, stdio.h and stdlib.h. And we have a constant defined here called a max. So which will always carry a value 15. Always carry a value 15. Okay. So with the queue, as we have discussed, we can perform two operations. One operation is called insertion and other one is called a delete operation. Now here we have a locally defined arguments for an insertion. That's a value. Then a queue, size is not defined here. Then a pointer called rear. Pointer called rear. So value is a variable, queue is an array, and rear is a pointer. So what do we do first? First, we check the condition of the rear. Whether rear is, that means it's a pointer actually. The rear will have some value. Rear will have some value, and to which it's pointing. To which it is pointing. So the value pointed by the rear is less than max minus 1. If it is 0, we are starting. it will be max minus 1. Okay, so if it is less than max minus 1, then what do we do? It's insertion. Okay, so we can insert a value. How do we insert a value? By incrementing the rear pointer by 1. So whatever value that's used here in the memory, which is pointed by the rear, will be incremented by 1, and that will become a new address. That will become a new address. Then Q of the rear. Again, it's a pointing reference only. It will dereference from the memory, and that value will be there. So let's say it's x plus 1, because already we have x. So x plus 1. Then to the location Q of x plus 1, the value it is which is obtained here, new value will be entered into this particular location. Okay. By chance, if the value loaded onto the memory, which is pointed by the rear, is greater than max minus 1, that means no more we can enter the value. Then we just print off on the we print it on the screen. The queue is full, new values cannot be inserted. Okay, then coming to the deletion part. Deletion, what we have to do? We have to use the front variable. Okay, so now here, when here we use now a pointer called a variable, a value pointer, and a Q array, and also the front pointer and a rear variable. Now, where again it is a pointer, means a value is stored onto a memory. Let's say it is y, for an example. Now this is being pointed by the value. And similarly, what do we have? A front. Front is also, let's say A, and this is pointed by front. Whereas the rear is a simple variable. Here. Okay. Now the value which is dereferenced from the pointer front, if it is equal to rear, front and rear are at both position. That means what? It means that Q is empty. We cannot delete any value. So no values to delete. Okay. Now, else what do? We increment the pointer. We increment the front value by 1. So again, by dereferencing, we are adding the value 1 to the memory location, and to the new address, we generate a new address here. So after generating new address, to this new from this new address, the value will be fetched, and that will be loaded onto the value memory. Where is this value? Here. That will be loaded to the value. So straight away, it's going to load a value onto this. So that is how basically the insertion and the deletion takes place in a queue. Now coming to the main program, we have written for two functions called insertion and deletions. These are the two functions. Now coming to the main function. In the main function, what do? We use two variables called n and val of integer type. And Q is defined as an array of size 15, because the max is set to be 15 earlier. Max is set to be 15 here. Then two pointers called front and rear is being used, and both are set to the value -1. Because when an array is declared, the array starting index will be 0 and ending index will be n. Okay. So now here, when you say -1 means which is out of the bound of an array. Okay, out of the bound of an array. So we set the rear and front both pointed to the -1. That means it's not pointing into the queue, but it's out of the queue. That means to say that. Okay. First, what do? First, we are planning to start the operation. What? Insert operation. Okay. So let us say that here, first we'll say list the elements to be entered. Then the value will be entered here. Then we ask for the operation, the insert operation. So that's by calling the function. So we pass the value q and the address of the real. So it will be entered here. So once the value is entered here, then it asks again you want to insert a value. That means again you want to enter. So depends on our convenience. We can select. If you want to continue, you can press 1 and that will be entered. So we have to repeat this operation. We have to repeat this operation for some time. So at least once it should get executed. That's why we placed between do and the while loop. As long as n is equal to 1, the insertion will continue to take place. Okay. When n is greater than 1 or any other value, n is any other value, then it will come to the next set of statements. When it comes to the next set of statements, what is there here? It display on the screen, enter the element value, delete an element. So we want to delete means you can press, you can enter 1 here. Then the 1 will be taken here. Then as long as it is equal to 1, it will ask for deletion, and it will also show that because it will come here. The delete operation will come here, and delete will delete the value and it will place it onto the uh, pointer variable. And now what we do, then we can print that value here. We can print that value here. So the value that has been deleted will be given here. And also to delete an element, that means you want to continue, again you can press 1 so that it will continue. And as it continues, again it will go for a deletion and value will be deleted. If you want to continue the operation, entire operation once again, what we can do, you can ask for user to enter 1, and user enters 1. You can check it whether it's equal to 1. If it is 1, entire operation can be continued one more time, so that we can do the insertion and also we can do the deletion, whichever you want to do. And if you want to come out of the loop, press any other value other than 1, that will be exiting the loop. Now let us see the simulation part of this. If we look at the simulation part of this, here the same program, whatever we had discussed, the same program, it is there here. And now straight away I'm going to run the program, and here you can check it out. First it asks that list the elements to be entered. So I'm just giving some 4, and then it asks me whether you want to continue to enter. Yes, I want to enter. So we'll just enter 1 over here. Then it will again ask me, yes, I'll enter 5 now. So then again it will ask me to continue. If we want to continue, I'll continue. So I'll enter now 6 over here. Then again it will ask me, again I'll continue. Then I will enter 7 now. So now if you look into it, how many elements I have entered into the queue? So I've entered 4, then 5, 6, and 7. 4 elements I've entered into the queue. So as I entered, what pointer must have been increased? The rear must have increased. Okay. So now coming to the deletion part, I just give some other value. I'll come out of this inserting loop. So now it asks me to delete. So to delete, I can enter 1 here. So when I delete, now what will happen? The friend will get advanced. So as the friend get advanced, from -1, it will be equal to 0. And it indicates that the value that has been deleted is the first value that we have entered here. Okay. So again, if I enter delete element 1 over here, so next the 5 will be deleted and the front will be incremented by 1 over here. So initially it is -1, then it moves to 0, then it is 0, then it comes to 1. Okay. Thank you.